Morning students. In today's class, we'll be doing a practical on chloride ion testing, and this is being done by one of my students, Akshat Sharma. Hi Akshat. Hello. Okay, we begin with the salt. He'll take a pinch of salt in a tester and add dilute sulfuric acid. That is the first step to anion analysis. And he will be observing evolution of a gas. So he's adding dilute sulfuric acid, and you can see there is no evolution of a gas, which means that the first four anions are absent, namely carbonate, sulfide, and nitrite are absent. Had there been a brown gas, it would have been nitrite. Had there been any other gas, it could have been the others. But for carbonate, you get brisk effervescence. That is something like the bubbles that you get on adding ENO to water. So there are no bubbles. So all these four, carbonate, sulfide, and nitrite are absent. Discard the contents of the test tube, wash your test tube, and move to the second lot of anions by taking the fresh pinch of salt. He's taken a fresh test tube also. That may not be done by you. You can use the same test tube. Again, take a pinch of salt. This time you are to add concentrated sulfuric acid and give a close observation for any evolution of a gas. Add a little more of concentrated sulfuric acid. Do it with a dropper. You have to be cautious with sulfuric acid. You can see there is bubbles there, and these bubbles illustrate evolution of some kind of a gas, which can be verified by using a glass rod dipped in ammonium hydroxide solution near the mouth of the test tube, and you can have a look. Evolution of dense white fumes. Retry. Wait a minute. Use a freshly prepared ammonium hydroxide solution. Use that. Put a glass rod in it. Now, we are not getting a much clearer view. I think we'll repeat it a little. Add a little more of salt to the test tube. Leave the glass rod. Add a little more of salt. And be a little quicker because the gas perhaps has already escaped. Fine. Add sulfuric acid and quickly then bring the glass rod with the ammonia. Yeah, you can see the evolution. Fine. That's one of the preliminary tests to show that it could be a chloride, and you can see the whole test tube is in fumes of ammonium chloride. Moving ahead, moving to the confirmatory test of chloride, we'll discard the contents and use the original solution. In some books, it's written as water extract. What do we mean by the original solution? Original solution means salt plus water. Make the original solution. Take a pinch of salt. Add water to it. Shake it to dissolve it completely. Once your original solution is ready, add a little more of water. Fine. Take 1 ml of this in a separate test tube. Because we'll be using the OS, if you need it ahead for your cation analysis, you can keep it for the cation analysis also. 1 ml of OS. To this add silver nitrate. Silver nitrate is always added to the original solution. On addition of silver nitrate solution, you can see the formation of a white PPT. This white PPT is of silver chloride. Now to confirm further, you need to dissolve this PPT in ammonium hydroxide. Since our aim is to dissolve the PPT, there is no point in taking this lot of PPT, discard half of it. Fine. With the leftover PPT, add ammonium hydroxide in excess. and observe the dissolution of the silver chloride. That's it. It's becoming clearer. You can add a little more if you want. Excess of ammonium hydroxide should make your test tube contents clear, and they are, which shows that the confirmatory test for अच्छा आया.